Hello guys, welcome back to my channel. This is Vinayak, and today I'm going to discuss about a worksheet that is given by my teacher. And this worksheet is actually very useful, and it is taken from different past papers of IGCSE. So now let's start with the worksheet. This is our first question. In a laboratory, an experiment is carried out to measure the acceleration of a trolley on a horizontal table when pulled by a horizontal force. So the trolley is being pulled by a force that acts as shown in the picture. So the table shows here the details. So now they're asking us to draw the suitable graph. So in according to the table we should use it. So let's point the details first. So here they said 0.5 newtons. 0.5 newtons will be 4. Okay, let me make the size smaller. uh, yeah, now 0.5 is 4, so this is 4, so let's mark this point as 4. This is 4. Then the next point that they said is 6 newtons and 0.85. So 6 newtons, which is somewhere over here. 6 newtons and 0.85, so it will be somewhere here, close to 1. So let's estimate the point to be here. Let's estimate it to be here. So the next they said here is 10 newtons. 10 newtons will be close to 8. Okay, maybe close to 12, somewhere here. Let's make 10 here. So 10 and 1.55, which will be over here. So let's estimate and make it be here. So next is 14 newtons and 2.25. So 2.25 will be somewhere in the middle over here, and let's estimate here's 14, so let's put it over here. So at the end you can just draw, but it should not be straight. So you can just draw from 0 to 4 over like this, then like this, then you can draw a straight line from here. So this will be how the graph will look. So let me increase the thickness so it will be easier. So this it will be like this, from here to this point, then from here to here, then the second point comes here, then from here we'll make the point come here, then it continues like this straight. So the next question shows is the graph shows that below a certain force, so you should find the value of this force. So in this they're telling that the force over here is not the same. So what we're going to do here is, this will be a straight line. So from here you just make another straight line from here, so it'll be somewhere like this. It'll be like this. It will, when once we draw a straight line over here, the value that is over here, it will be 1.2 newtons. When you check with the ruler, it will be 1.2. So the answer for that question will be 1.2. So we can write over here, let's write here 1.2 newtons. Let me make this bigger. Yeah. Then they ask next, a force smaller than in BI is applied to a stationary trolley. Suggest what happens to the trolley if there's any force, like something like that. So now we should check in over here. So here the 7, a small force is less than 1.2, a small force. So if you calculate like that, the answer over here will be like there's no acceleration, like there's no any positive or negative rate. So it be might mean a constant speed, something like that. So the answer will be no acceleration. I hope this is clear. The next is show that the gradient of a graph is about 5.7. So gradient is like we take the coordinates of the y2 minus y1 divided by x2 minus x1. So over here, if you go back to the graph, here it will be, let me reduce the thickness of this time, let reduce thickness. Then now it will be here. When you check the coordinates, you can just check any coordinates which is easier for you to point. So you can take, I'm taking what I got the coordinates. So I'm taking 14.4 minus 5.6. See, this is for the y2, for the y-axis, the coordinates for y-axis. So I'm taking for the x-axis now. So the x-axis will be 2 minus, I'm getting to the 2 minus 0.5. So if you keep this in the calculator, or if you want to work out, you can work out. But if you check in the calculator, it will be 8.8 or 1.5. So when you divided that two, it will become 5.87. So here, because we are not nearly estimating, like they told, showed that, so it's not, it is nearly. So it can be between 5 point something range, but it should not be 5 or more, or less than 5. So the gradient will be 5.87. This will be the final answer. The next thing, state the equation that links resultant force F, mass and acceleration A. So this is just simple, easy. Then just state the formula or with the that has F, M and A. So the very simple thing formula over here will be F. Okay, let me just use text. It'll be easier. So you can write, it can be F is equal to M times A. This is the simple equation. Then using a gradient from C, find a mass of the trolley. So in these graphs, if you ask for a mass, the mass, so is just the gradient. So the value of the gradient is equal to the value of mass. So this I use a gradient from C. The C we got as 5.87. So obviously the mass will be 5.87 because the gradient is equal to graph. So let me write here, gradient is equal to mass. So I hope this is clear. Now the next question tells us that to sketch a speed time graph for a trolley with constant acceleration. So here the constant acceleration, which is easy. So you can, it means here speed, not distance. So here speed and time. So constant acceleration will be a straight line from here to here. It will be a straight line. So you should use a ruler. Then the next question. Here they said a plane lamina with center mass x. This one x touches the ground at point P. Which diagram shows the lamina in equilibrium? So if they ask for equilibrium, which means that there's in this case of a lamina, it means that the center of mass, that is x, should be the same, like same line to the point of P. So if you check here, it is x is going like this, P is going like this, so it is not A. Then if you check B, here x is going down and point is coming up, so they go in a straight line, so the answer will be B here. The answer is B. So for, if you check for the reason, so we can, let's write the reason as the answer is B because the center of mass is in the straight line as the point of contact. This will be the reason for your answer why you choose B. So let's go to the next question. So here it shows that a graph. So from the graph they give, so we should study the graph first. So once we study the graph, we can read a question. Describe what happens to the speed of the car between A and B. So between A and B, So it will be because speed, time graph and time. So once it goes down, it means a negative acceleration, which is basically known as deceleration. So let's write a deceleration. Okay, so already pop up here, deceleration. Then between B and C, so between B and C is constant speed because it is moving forward at a steady speed, so it will be constant speed. It can be constant speed or steady speed. Then between C and D from here to here, it is in a positive acceleration, so you can just write acceleration, or you can write constant acceleration because it's going straight, so it can be constant acceleration. Okay, acceleration. Yeah. So the next question asked is to find the distance between the start of the town and the end of the town. Means from here, let me point it, which means from B to C. They're asking to find the distance. So it's literally easy to find distance. So from the point B, you make a straight line down. From point C, you make a straight line down. So even you do like that, here you'll get maybe 13 over here. Then here you maybe get it as 24. Or it's not like that, or you can do like 42 minus 18, so you get like that 24. Once you subtract from here, so here will be 42, sorry, 42. So now we got 13 over here, so we want to find distance between these two, so you can do 42 minus 13, which will be 24. So now we got the value of these two. Now it's easy to find distance. So the easy way to find distance is you already made it into rectangular form. So distance is so you can write this: distance is equal to area of the graph. So here the graph they said here is to calculate distance of B and C. So it's rectangular form. So you can write area. You can calculate area of rectangle. Will be L, the length times breadth, then which should be 24 times 13. When we once we calculate this, the answer over here that we'll get is equal to 312 meter. So here I wrote here you should focus because here 312 is not kilometers. They wrote here meters per second, not kilometers per hour. So depending on that, you write whether it's meter or kilometers. So it'll be 312. Okay, 312 meters. Let's go to our next question. Calculate the acceleration of the car between C and D. So the C and D from here C and D. So they're asking to find the acceleration, not the distance this time. So you'll do the same thing. You will bring this D the line of the D down. Once you bring it down, you'll get like around 54. Yeah, 54. Now you subtract from 54 from this to here. Here's 42. So when you subtract this, you will get it to be 12. Yeah, 12. So it'll be 12. So after you get these values, now you divide it. You won't find the area. So let me explain. Let me write it. 54 minus 42. The one I showed before is equal to 12. Then 31 minus 13, these all are from the graph, so you should just study the graph and answer the questions. So it'll be 18. So now to find acceleration, you will divide 19 divided by 12 because acceleration, so we'll divide it, so it should be meter per second per. So when you say per, means it's easy to understand divide by a distance over a time. So it will be 19 divided by 12. When you calculate that, you will get finally you'll get it as 1.58 meter per second square. So you can write an answer over here: 1.58 meter per second square. So I hope till here everyone is clear. So Next question tells that state how the graph shows that the deceleration of the car has the same numerical value as its acceleration. So let's write. So I think the possible answer for this is because let's write because so it explains 1 mark. So just explain a bit. The because when uh, when we divide it, the graph is decelerates. So we can write like this. Then conscious deceleration is constant as acceleration. So because if you don't understand this, then you can write this by the side. Deceleration is like you can write this that deceleration equal to 25 minus 13, that is equal to 8. I mean 25 minus 13. Okay, you do like this: 25 minus 13 all over 8. When you do this, the final answer you get is 1.5. So 1.5 meter per second square. So it will be the same thing. It's the same thing that I show you. It was is over here. So you can just based on the understanding you can write, because they should state a reason. So it depends like how you understand it. So this is the next question is a little tricky question. So I'm going to explain more on this. So they said figure 2.1, which is this, shows uniform plank A and B of length 2 meter, suspended from rope X and Y. The rope X and Y. The weight of the W is 210. The force X is P. The force Y is Q. State in terms of P the moment of P about B. So we all know that movement is, let me write over here, movement is equal to the force times perpendicular distance from pivot. This is the equation. So from here if you check the terms of P, so here the force is P, so you can write as P times the distance from here to here. The total is 2 meters. So if you subtract 2 from 0.5, you get as 1.5. So the answer will be P times 1.5. So that's the answer. So the moment of W about B. So the moment of W about B, here's 210. This is 210, and from here to here is 1 meter. 1 meter. So the moment of B will be 210. The value of W, that is 210 newtons times 1 meter. So the answer of this will be 210 Newton meters. Newton meter, yeah. So you can write down this is easy, 210 Newton meter. The next question. So here they said calculate force P, and over here the only thing the force they give is P to be 200, the weight, the moment of W, that the moment of the weight, to be 210 Newton meters. So to calculate the value of P, you can simply do it by calculating the moment of the clockwise and anti-clockwise moment. So you can write it as the name distinct within the A, P times 1.5 is equal to the same 210. So now it's easy, just change your subject. So you can write P is equal to 210 divided by 1.5, and the final answer of P you'll get is P equal to 140 newtons. Yeah, 140 newtons. So the value of P here will be 140 newtons. So I hope this is understandable. It just, you will calculate the clockwise, anti-clockwise, then you just check the like just make us the subject, the variable or subject you're going to find. So they said force Q. and the force Q is, so you can just write like P plus W is equal to like Q. So to make it easier, let's write like this: force P plus force Q equal to W. Let me make this small so you guys can see the actual picture. So after write this, so as we found the value of P is 140 plus Q with the thing we don't know equal to 240. That is the 210. That's the weight. Now you just made a Q a subject again. That's did for P. So you do 210 minus 140 and you get Q equal to 70 newtons. So you can write here Q equals 70 newtons. So this I'm just explaining, like if anyone has doubt on topics like this, on calculating the movements, the variables in like these questions, that's why I'm making this video. So like anyone who has doubt on like this type of questions can just refer it. So the next question, yeah. So here let me zoom in a bit. Here asking what's the moment of the force. So you can just write a basic definition that movement is the turning effect of a force about a pivot. Turning effect of a force about a pivot. This is just the simple and basic one, and just for 1 mark, so we just no need to explain a lot. So they're asking now we should calculate the W. So first we should study the image first. So we can write here asking that telling that the mass of a rod is 0.08 kg. That's the W, but it can't be possible W because there's a mass. So now to calculate the weight is like the mass times the times 9.8 on Earth. So to calculate W, you write the mass that be 0.080 times 9. Okay, not times 9.8. When you try write this, the answer you get for this is 0.784 newtons. So this is the weight. So the answer of this will be 0.784 newtons. Then asking the moment of W about the pivot. So here the moment of W that about a pivot. So W is the weight and the pivot is this that they already pointed here. So it's easy again, 0.784. Now you'll multiply with the distance from here. So from here, from W that is over here to here is 0.25 meters. So times 0.25, and when you multiply that, the final answer you'll get again is 0.196 Newton meter. So the answer, the right answer here, 0.196 Newton meter. Now they're asking the moment of F, the force F about the pivot. So this is like there are a lot of working, so I'm going to show you guys. So first here calculate the moment of F. So it can be 0.196 is equal to F times 0.75. So after you get this, you can make F a subject again. F equal to when you divide 0.196 divided by 0.75, you get it as 0.26 newtons. So they're not asking to find the value of F, they're telling you to find a movement. So you do 0.26 times the distance that they gave, and that is 0.75. So 0.75, and the answer you will get is equal to 0.195 Newton meter. So the value, the answer for this will be this 0.195 Newton meter. So we are done with this question. We're not done yet, and not to find a value of F, and we already found it over here. So just write as 0.26 newtons. We already found it over here. So the next question is again the graph, and for like this graph, while using a computer we won't be able to do it, but we should, to make it easier, you can just count how much lines is over here, then you divide it by the how much the value of this, so you get each grid was the value of that. So here it will be, let me make this the pen tick so that I can show you the dots. So here 0 is 0, so you can write here 0. Then 1 is 21, so when you zoom in you can see here it will be this. Then for 2 is 40, so 2 is 40, that will be over here. Then 3 is 51, 3 is, so let's make it somewhere here, let's make it somewhere here. Then 4 is 82, 4, so 82 will be somewhere here. Then 5 is 103, so 5 is 103, so let's make it somewhere here. So now when we are going to draw the line, so it will be basically a straight line, so don't mind about this point. There's a question there, I'll explain the time. So you just draw a straight line with a ruler like this, a straight line like this, make sure it passes the points. So let me tell why you're ignoring this. So there's a question like that below that you can see it. Now they're asking, the student appears to have made an error, so which result is this? So here every point over here is agreeing to the Hooke's law, so it's only this point that is for they're asking which force. So let's write the answer over here as 3 newtons, because that's the only odd one out, because others are going in a straight line, is because of that we have to bend it. So it is that place where we're going to do that. Now they're asking, in ignoring the incorrect result, draw the best straight line. So you can just make another point, you can just bring the point somewhere up, and you can just make a straight line like that. Okay, like then it's not like that. Here we shouldn't draw the line before that. So they say ignoring the incorrect result, so we should ignore this, like how I told you before. We should ignore this one, then draw a straight line. Then they're asking, state and explain whether the spring is obeying Hooke's law. Yes, it is obviously performing. Only that 3 newtons that is specific, not doing obeying it. So the others are obeying, so we can write yes. We can write yes, it's obeying. Okay, not yes, it's yes, because we can write this a reason, because the extension of the spring is proportional to the load, which means like if you still understand this, after I can explain it. So to the load, so this is a basic one. So I'm telling, like, if you don't know whether it's proportional or not, then you just subtract this, and when you subtract, everything will be the same, like the value you get will be the same. So using that you can perform it, or you can, by looking at the graph and studying it, we can do it. So next question, describe how the graph might be shaped if the student continues to add several more weight to the spring. So here we write, obviously when you add more weight that it can hold, it will cross the limit of proportionality, which is the limit to it, like it's the spring stops obeying the Hooke's law. So the answer of this will be to cross the limit of proportionality, and the graph, and the result of this, and the graph will be curved. Okay, proportionality. Okay, so we are done with this. So let's read next question. The student estimates that if he hangs a 45 newtons load on a spring, the extension will be 920 meter. Obviously it's not, it's unrealistic. So let me write this. So when I write, you'll understand. So when we divide, like let's divide 920 meters. Okay, what happened? Okay, when we divide 9, what is happening? Okay, when you divide 920 meters, okay, millimeter by 45 newtons, 45 newtons, the answer we get, it will be in decimal point. We get a decimal number. So in this case, it's unrealistic, because if it's realistic, when you divide it, it should be a whole number, or it should be a natural number, or an integer. So if it comes in decimal point, means that it's either that the spring has crossed the limit of proportionality, or yeah, it's because of that. So let's go to the next question. Actually, this my physics teacher made this worksheet, and it's like 39 pages. So I'll be dividing the video into part 1 and part 2. So once we get into half of it. So let's see, figure 1.1 shows apparatus. So let's study the graph. So now that after read and studied it, explain how the mass produces a force to stretch the spring. So it's obviously the load. It's because of the load that the spring stretches. Explain why force is a vector quantity. So just need to write what is a vector quantity. So because it has magnitude. Magnitude is basically the size, the magnitude and direction. Yeah. So the next question again is about a graph, and here it shows the graph update. The two springs are stretched. State which spring is more difficult to extend. Core values from the graph to support the answer. So here, if you calculate, you will get the, like, so the tend point from here. You will do the formula F equal to, like, here I tend to find. So they said how difficult to extend. So we check whether which one has the more spring constant. So the formula to find spring constant is K equal the spring constant equal to the load divided by extension, or unit extension. So now after we do this, we should find the points over here. So let's find it. So from here, if you zoom in, this is from here, like this graph is obeying the Hooke's law. But if you check here, maybe from here the spring is starting to bend. So let's make this value as 25, and here let's make it as 18, because here also is bending. So let's make it as 18. Let me reduce size again. So now for the spring one, that's like, let's make it as K1. So let's make this K1 equal to 20 over 25. Thus you calculate the force and the extension. So 20 over 25, that's for the K1, you get 0.8. K1 is the spring 1. So now let's calculate first K2, that will be spring 2. So K2, it will be 17 over 29, and the value you get for K2, it will be 0.59. So they said state which spring is more difficult to stretch or extend. So this is easy to understand, that the higher the spring constant, the more difficult it is to stretch. So in this is the spring 1, that is that, okay, let's write that has more spring constant value, so it's difficult to stretch. It will be difficult to be extend. So the next thing is, on the graph of spring, to make a point P at the limit of proportionality, explain a choice of point P. So let's write. So it will be the answer of this will be, because the graph is starting to bend or cross the limit of proportionality. Yeah. So the next thing is, so after this page, I'm going to mainly focus on the working problems, because the others that we're going to write and explain is basically to understand or study the graph or study the object. So from now, after this question, I'm going to focus mainly on the working problems one. So you can write, use the graph to find a difference. So let's write here spring 1. Spring 1, when you, if you do with a graph, you'll get it as 18. It'll be 18, like how I subtracted and show you from the limit of proportionality. Then spring 2 it will be 25. So to get the extension, difference extension, you can just subtract 25 minus 18 and the answer you get is 7 mm. So the answer over here you get is 7 mm. So after now I'm going to focus only on the those parts with the working and all. So now asking, a spring of original length 3 centimeters is extended to a total length of 5 centimeters by a force of 8 newtons. So assuming limit of proportionality or spring not extended, calculate force needed to extend a spring even length to 6 centimeters. So now we should find the value of 1 centimeter when it's extended. So you can, this is easy, 5 centimeter equal to 8 newtons. So you should find when 1 centimeter, you'll just divide 8 by 5 and the answer you'll get is 1.6. So 1 centimeter 1.6. So if you want to calculate F equal to 6 newtons times 1.6 meters. So the F will okay, not here, it is 6 centimeter. Okay, let's not add this units, it will be confusing. So the answer will get to be 9.6 newtons, because they said find a value of force. So the answer of this will be 9.6 newtons. The next thing is telling that the arrangement of an experiment on movement. So the spring exerts a force on a meter rule. On figure 3.1, mark the another quantity which must be measured to find the moment of the force F. So just write distance, because they already give the force, and so the movement to find is left is a distance, so it will be distance. Then the next thing, the now asking, sketch how the moment of the F is calculated. So just you multiply. Now I'm just writing the formula, you can explain your own words after that. So you can just multiply the force times distance. So the next thing is showing here a bicycle, and now we are done with the graph, the spring, and about the speed time graphs, then calculating distance, acceleration. Now we are on energy, how to calculate energies. So let's check. When fully charged, the battery can deliver 600 watts for 60 minutes, that's 1 hour. Calculate the energy in joules stored in the battery when full charged. So then asked to find the energy. So you'll state the energy formula. Energy equal to, I'm writing P as power. Okay, let me write power times time. So the power 600 watts. So now you calculate 360 minutes into seconds. So when you calculate that, you get as 3600 seconds. So when you calculate energy, it will be 216 1 2 3 4 so joules, watts per second, that you can write it as joules. So the answer over here will be 216 that much joules of energy is given out. So state a form of energy stored in the batteries, obviously chemical potential. So it's very important to write potential as the battery stores the energy, and whatever stores the energy is like a potential. So the next question is, the bicycle has a motor with an axle, electrical input power 250 watts. Calculate time for the battery. Okay, so let's write time is equal to energy over power. So we can write 216 divided by 250. Then the answer you'll get will be 8640 seconds, 8640 seconds. So you can write again over here in the space given 8640 seconds. So the next question is, you can write in your own words. So what I suggest in this answer is the environmental benefit, eco-friendly bicycle which has battery, there's no pollution. So you can write has no pollution, and there is no fuel because nothing is burned to release energy. It's already stored using maybe electrical energy. Nothing is burned and doesn't cause any negative side effects. So those are the two answers. Then the next question, let's see the question on this one. Let's see this. So this is a nice question. Calculate GPE, that's gravitational potential energy. So once you read and understand, we can write. Uh, Now we can state the, and the first we calculate the weight. They get a mass 12 kg. So you write weight equal to 12 times 9.8. So you get a weight value to be 117.6 newtons. So now you write GP. GP is basically the weight times the difference in height or the change in height. So you can write 117.6 times 3 because they said 3 meters above. In the question it say like that. So the answer you get is 352.8 joules because energy is written as joules. So the final answer over here will be 352.8 joules. So the next question, the will over here, calculate the useful power output. So the power output, they said calculate the power output basically as the total power given out. So power equal to energy over time. So the energy we calculated in our question, it was 352.8 all over 60 because they said every minute means 60 seconds. So when you get 5.88 joules per second, which is joule per second is watts. So we can write as power equal to 5.88 watts. So unless or until they specify the question that we should write in a whole number or not, we should write it as a decimal number because that will be more accurate. So the next question we can do is, let's do this question. Let me see the nail one. Let's see this. So it's showing a man squeezing a nail. So they give the how much force is exerted and the area of the pin. So let's calculate pressure. So the formula to calculate pressure is pressure equal, let me write capital P. Pressure is equal to force over area. So when if you do like that, it will be 84 divided by let's write the whole thing 6 times 10 power exponent uh, wait, exponent minus 5. We're just basically writing the total area. Then if you keep in the calculator, then you'll get the answer to be as 1 4 1 2 3 4 5 1 1 2 3 4 5 Newton per meter square. So this will be the final answer. So you can write the final answer again over here. 1 4 1 2 3 4 5 1 2 3 4 5 Newton per meter square. So this is state the value of a force exerted on the pin. So we'll do the same thing over here, but so the next question we're going to look now is let's focus now on, because I'm not looking at all the questions because some questions are just repeated, so I'm just selecting some questions that we can do. So now let's check about the water pressure. They given somewhere a water pressure. I'm just focused on some main topics. So this is the picture that they gave, and they said the pond is kept at a depth of 2 meter, density is 1000 kilogram per meter cube. Calculate the water pressure. This is a nice question. So because the pressure in liquids, it will be pressure equal to the density times 9.8 as the acceleration due to gravity times the depth. So you can write as P equal density is 1000 times 9.8 times 2. When you keep this calculator, you'll get it as 19600 pascals. So you write it as like this. So the final answer 19600 pascals. So the next question that we can look is, let's see this question, because I have seen some question like this, not in every question, not like every question paper, but some question paper have questions that are like related to this. So let's check. So they're giving here a fan blade, and the wind is blowing back towards a wind turbine speed of 12 meters per second, and they scale a mass of the air that is 7,500 kilograms. So they say calculate the kinetic energy of the air traveling at 12 meters per second square, 12 meters per second, which passes through the circular area in 1 second. So now you should calculate kinetic energy, that is half now 1 by 2 times mass times speed square. So now when you do like that, you will get 7500 times 144 the whole divided by 2, and the answer you get for this is 1 2 3 4 54 and 4 zeros. 1 2 3 4. You will get this much kinetic energy joules. So write 54 1 2 3 4 joules. So this will be the answer for this. And the next question is showing that a turbine converts 10% of its kinetic energy of the wind to electrical energy. So we should calculate it. So let's check. 10% 10 by 100 times 54 1 2 3 4. When you check this, you will get a final answer to be 54 1 2 3. You get a decimal zeros. Then after you get this, you subtract this with the first one. 54 1 2 3 1 2 3 4 minus 54 1 2 3. So when you subtract this with this, you get 486 1 2 3 joules. This is the energy that's transferred. Now for the power, you will do energy power equal to energy over time. So the next will be 486,000 over 1. We could have said here 1 second, so it will be 48600 watts. This is the final answer. So next will be 48600 watts. So let me check at the next question which to do. Okay, I think this is the next question. This question again on energy. So now it's asking a car of mass of 900 kilograms with a steady speed 30 meters per second resisted for 2000 newtons. So again the kinetic energy. So we can write what is so 30 square is 900. So you can write 900 times 900 all over 2, not 52 over 2. So you get the answer to be 405,123 joules. This much joules of energy. So this will be the final answer. 405,123 joules. Now calculate the energy. So again you'll do now you're calculating energy. Energy equal to force times time. So if you do this, the next thing you'll get is 2000, because at 2000 newtons the car exerted 2000 times 1, so you get 2000 joules. So energy over here is 2000 joules, because we get here 2000 because they said here the car is having resistant force of 2000 newtons. So using that you'll calculate it, the resistive force. So now asking a minimum power, that's basically the asking to calculate the value of power. So power, you all know by now, power is energy divided by time. So 2000 by 1, you'll get as 2000 itself watts. But please don't forget to add the units, because very important. 2000 watts. Let me check the next question. A working question. Okay, let's check question number 4. A student wishes to work out much power she uses to lift a body. Her body mass is 60 kilograms and a vertical height of stairs 3 meters. She takes 12 seconds to walk up the stairs. Calculate the work done. So far I didn't check any question work. So let's check. So work done is near the formula of energy. So right, work is force times distance. So now you write work is 588 times 3. So now we are wondering how is 588. So here they said so you write here, because 60 kilograms, so you calculate 60 times 9.8. when you do 60 times 9.8, you get it as 588 newtons. So that's the basic part we got over here. Then you get the answer, final answer 1764 Newton meter. 1764 Newton meter. Now calculate a power again. So just do the power formula, but this is not energy or time. Now we are using, because there is set power, so power equal to work over time. So you get us 1764 and they said 12 seconds, so by 12, when you get this you'll get us answer 147 watts. So power is equal to 147 watts. So let me select the next question to do. We are almost done. only 9 pages, so I'm just selecting. So let's check this question now. This one here, this girl is a dancer. First she exerts 500 newtons. She stands with the both feet flat. So the area of her shoes in contact with us. So they give the area of the shoes, so which is 400 centimeters square. So calculate the area, I mean pressure. So as pressure is force by area, so you can write as 500 by 400. So when you calculate this, so you get as 1.25 newton. It's not newton per meter because they said centimeter square, so you write centimeter square. So the answer right here, just like 1.25 because I already get units in the side. So let's check the next one. So now showing that she stands at the points of her feet. Her new area of the contact flow is 10 centimeters square, which means it reduced. So describe what happens to the pressure. So obviously increases, the pressure increases. So the next question. So now she dances at one point. On one point, she cannot remain at one point for a long time because it may damage her toes. Suggest why? Because now the force before she used two legs and is 10 centimeters square, and now she uses only one leg. So the force of 500 newtons and only like half of that, so 5 centimeters square, which is like small area and a large force applied to it. So it's basically because of high pressure exerted. Yes. So let's check uh, this question again about weight again. So this is again basically about the anti-clockwise and clockwise movement. So let's say to calculate the value of A, the weight of A. So it's easy this time. 4 times 3 equal to 2 times A. So you write 2A. So 12 is equal to 2A. So you make A a subject. So A is equal to 12 by 2, that's 6. So A is 6 newtons. So weight of A here you write it as 6. So then let's check the next question. Let's check this. The diagram shows uniform 120 newtons applied pivot at one end and carry equilibrium at F. Find the value of F. So you write here 120 times 20 to find the moment. 120 times 20, that's the clockwise movement. So equal to anti-clockwise movement, that's F, times 80, the distance of that. 60 plus 20, 80. So now you write, so you get 2400 equal to 80F. So you write, now you divide F equal to 2400 divided by 80, you get as 30 newtons. So F is 30 newtons. So let's check this question. This question about center of gravity in a double-decker bus. There are two passengers compartment, one above the other. So the platform is used to test the angle of bus make horizontal cutting grip but become explain why bus begins to topple. So this is easy again. So it's just based on understanding. So because the weight of the bus is the weight of the bus is big. So the central gravity will be probably around probably over here. This will be the center of gravity. So that acts over there. So because it's tilted to a particular angle, because it is tilted, so maybe it will obviously topple because the weight is as the center of gravity is not stable. So that's the answer. So because the center of gravity won't be stable, So now let's check a last question. The last question. I know it's 1 hour, 59 minutes by now. So this is the last question I'm going to solve. So a bus is, let's read a question. A bus is traveling along a straight road. The bus and the driver have a combined mass of 16,000 kilograms. Oh, wow. When there are no passengers in it, the passenger has 73 passengers. The average mass of each other passenger is 65 kilograms. So now you will write this: bus plus driver is 16,000 kilograms. So passengers will be uh, so the average will be 73 times 65, which will be passengers will be 4745 kg. I'm not writing kg. So now they're asking total mass, so it's be easy. So total mass, you'll add both of them, 16,000 plus 4745, and the final answer you'll get is 20745 kg. So this is mass, so write with the unit 20745 kg. So I'm gonna look at question number 9. Okay, let's look at it. It's a small one. So the fully loaded accelerated bus uniform from speed of 40 meters per second. Okay, now that asking calculate resultant force. Wow, we didn't saw any question resultant force yet, so let's check that. So to calculate resultant force, it will be F equal to the mass times velocity. The velocity is basically the speed. The mv, you can write mv minus mu, that will be mass times velocity. Okay, let's write as mv. So just basically the mass minus mass times the final velocity minus mass times initial velocity, that is the starting velocity. So it will be it will be 207, okay, all over t. I forgot the t. Then you will get us 20745 times 14 minus 20745 times 0 all over t, that will be 20. So when you keep this calculator, you'll get it as 14521.5 newtons. So this is the final answer of the force. So the F is 14521.5 newtons. So just look at the last question, then we can end. So now as the diagram shows a handle with three forces, each 100 newton applied to it. The hand is free to move, means that it is left in a free force. What is the effect of these force on the handle? So let's check the three conditions are needed is the force should be far away from the pivot to make it easier to move for a less movement. So I think this will be the one furthest from the pivot. Okay, it's not this. Wait, how to use this? Okay, it's not this. It is this one, because if you move the pivot down, it doesn't make any sense. So once it goes like this, a clockwise, it will be anti-clockwise movement. Sorry. So what's the effect of this force? So we can write it as the turning effect, movement. So this is the answer. So I know this worksheet is long, but this work, like I'm telling you again, this worksheet was made by my physics teacher. He's not a James, and he struggled this much to make this worksheet for us. And yeah, and I hope you guys made you understand, like I made you understand on any doubts you had in these things. So the next video I'll be posting later will be on another subject, so I might be doing on biology or something like that. Yeah, So like usual, now please subscribe to my channel Vinayak Vinay, and please share this video, like it, subscribe, and stay tuned. Bye.